Alright, the next one is we are going to part 2. Actually, we are covering the series circuits. Okay. Here, what are you going need to know, because actually this is a refresh of what you already learned before this. Series circuit is electric circuit that have only one path, through which electricity may flow. It usually used for devices that are connected in the circuit for safety or control. That's why you need to put every equipment that you have in one series, so you could easily control it, or you could easily secure it with having at the same circuit. You could install, for example, resistor or fuse. Okay, the next one is this is the figures. Okay, this figure actually show 4 heater being connected in series. We have R1, R2, R3 and also R4. This is connected in series. So what happens when you have current over here, you go from R1, R2, R3 and also R4 and then going to neutral. This is an example of the series circuit. Okay. Actually, this I leave it here because this slides is being compiled first by Dr. Ahmad bin Boss. The next one is okay. The series circuit also contain switches, safety device that are need to maintain safety operation and equipment components. In figure 4, for example, here we have a high pressure switch, low pressure switch, and we have thermostats. This is why we have all the switches, because actually these switches are need to control the electric motor. What happens here, because it's been in series, so the current have to pass each of the what we call it here sensor each of the sensor, so that if it pass everything, then the electric motor will be moved. So that's why it put in series. If one sensor is failure, and then what happen? The current cannot flow, and the motor will not operate. Okay, that's why we put in series. For example, here we have a high pressure switch. What happen when the sensor detect very high pressure in the system, so the electric motor will not function. For example, this electric motor is to compress a compressor, so it detect high pressure. And then we have another one is low pressure switch. If it detect low pressure switch, means the system, perhaps for example in the HVAC, the system without refrigerant, so the pressure is very low, up to certain load that being setting by you, so the motor will not operate. And then we go to thermostat. Thermostat is a sensor that to measure a temperature. So when it detect the temperature already achieve whatever you want to achieve, then the electric motor will not move. Okay. In the example here, as you can see that we have a high pressure switch, low pressure switch and thermostat. Here you could see there are two different arrangements. Okay, we could see the first and second one. So let me draw. For example, we have here high pressure switch. So they put over here and going there, and one over here. Okay. This is high pressure switch. Alright. Oh, sorry, the drawing is a bit different. So we put over here is high pressure switch. So as you can see, this is a low pressure switch. So low pressure switch is somehow like this. This the difference that this point and this I should say this one, this line is below and the other one is above. So this is low pressure switch. Low pressure switch. This is high pressure switch. Okay, from this one, actually, what you could know from just reading this kind of symbol. So actually, when the circuit is function, mean that this switch should be touch each other. This is salah lagi. Okay, this is the system should be function lah. If the line is touching to another point. So when the pressure is high, so what happened? Actually, this is being forced up. So what happened? Then it go back like this. So being when the high pressure is high, then this line is already move up. So this is another one. When the pressure is low, then this line will be dropped below this point and cut off the wire. As you can see, the other one is thermostat. For example, here it's also below. Thermostat below. So let me draw the thermostat. Okay, thermostat is somehow okay. This is thermostat. Probably to put a T. Okay, temperature. So thermostat, they put this line is below this point. So what happened? Is go like this. Means when the temperature is high, the temperature is high. For example, you set 24 degree. Mean when the temperature is above 24 degree, the motor will be operate. When the temperature is below 24 degree, this will become like this. The symbol like this. Okay, and it will cut off the wire. Okay, if for example we have another one, also thermostat, but the point is above the line. Okay, this is thermostat, but this point is above the line. What happened? The system will be operate only when you set to 24 degrees. The system will be operate only when the temperature is below 24 degree. When the temperature is above 24 degree, this line will go up and the line will be cut off. Okay, this is how to read this symbol. Okay, let's continue. Okay, here as it states that if any safety control opens, the circuit will open and stop the component. Here, when you said that safety control open, this is safety control actually, because it's pressure, high pressure, low pressure, and thermostat. When it's open, means it's been the circuit was open lah, will not close like this, touching the line. So when it open, then the circuit will open and stop the component. Here is the component lah. So there will no current move to the electric wire, electric motor. Okay, sorry. Okay, the next one, let's see. Safety device should be connected in series to ensure that unsafe condition will be cut off. The load being protected. So the load here we have the electric motor lah. Electric circuits are used in the electric circuit of heating, cooling, refrigeration equipment to operate the equipment and maintain the desired temperature. So this one be explained before this, because that's why we have a thermostat over here to maintain the temperature, and we have heating and cooling because it has high pressure and low pressure. When we have a compressor Okay. Figure 5 shows series circuit for resistant heater of different ohms. Calculate the total resistance, the amperes, and the voltage drop across each heater. Okay, each heater here means R. So I give you time. Please calculate it. Calculate the total resistance. You have to find R total, and then calculate the I, ampere, and voltage drop across each resistor. Okay. All of the exercise that we put that being in this slide, I will put submissions link for you all to submit. In my classes, normally I 100% urge everybody to do their own work. Actually, if you don't know, just ask your friends, look at book, read the back, and no harm if you ask your friends. So how to calculate, because this is actually a refresh on what you have learned before this. Okay, take your time and calculate, and also submit it. Use the link that will be given later on. Please ensure you calculate that, because I'm not sure whether this one will be in the test and so on. So make sure you calculate it. Make sure. Alright. Okay. So this is the answer. I'll not give you the answer, so please submit it. Thank you. We'll go to the next slide. Okay, before this we go for the series circuit. Now we go towards the parallel circuit. Parallel circuit in electric circuit has more than one path. This is one path for light bulb, another path for fan control, fan motor, another path for compressor, another path for heater. So you have more than one path. And then the parallel circuit is designed to supply more than one load to the system and control the load separately. Electric device, or we could call it as loads, are arranged in the circuit so that each of the is connected to the voltage conductor as shown in figure 6. So here the benefit are, when the lights is off, the fan still can move. When the compressor is off, the fans also still can move. The heater is off, the compressor and the rest still can move, still can function. That's the benefit of it. But the disadvantage you cannot control, because you have to put the fuse, for example, a circuit breaker in each of the paths to control it. Line voltage is the voltage supplied to the equipment from the main source. This is term actually. This is line voltage. L1. This is supposed to be okay. This is N. And neutral. This is live 1. Power source typically has a value of 115 or 240 volts. The parallel circuits allow the same voltage to supply to all electric loads connected in parallel. So here, when you have 120 volts, so this is 120 volt, 120 volt, 120 volt, 120 volts. Okay, the next one we have open circuit. This is open circuit. Okay. Open circuit is a circuit when the paths are being interrupted or open at the some point in the circuit, and that current will not allow. So here we have a switch, for example, so the current will not allow. And then we have fuse, for example. Here the fuse is already broken, so the current will not allow. This is an open circuit because this is an incomplete circuit. Switch is open, fuse is burned. So the open circuit could be intentionally or unintentionally. Why? And when? Short circuit. Okay, what is short circuit? Short circuit is a circuit in which electricity has found an alternative path to return to the source without going through an appropriate loads. So this is short circuit. You can demonstrate this easily by taking a fine piece of wire connected to the both of positive and negative terminal of a small battery. The wire will heat instantly and probably melt. In most circuit, this high amp represent a dangerous situation that could cause a fire or electrocute someone. Okay. This is short circuit because it doesn't have the load okay, directly from positive to negative. Without going to appropriate load. That's why it doesn't have load. There will be short circuit between these positive and negative sources. Electrical energy supply to electrical circuit is called electromotive force. This is terms. Electromotive force is measured in volts. In heating and air conditioning industry, the nation often includes proximity to 24 volts. This is what are the voltage that being used in HVAC. Actually, they have three types: 24 volt, 120, and 240 lah. 24 for control circuit and the circuit board itself, and then we have 120 to control the fan, and we have another one 240 to control the compressor condensing unit and much higher voltage. Heating and air conditioning station is often around voltage that could cause injury or death. Here we come to the safety part, because when handling with aircon, actually one could be serious injury or could be death because you are handling the electric high voltage maybe. So one body can become part of electrical circuit in many ways. First, your body become part of electrical circuit if you come in contact with both conductor that is being supplied with power and natural conductor or ground at the same time. This is how it being connected when you have both hands connected to one place, or being connected to your hand, then your hand then at the same time goes to your body and direct to the ground, and your body become part of the path of the electric circuit. This is example technicians coming in contact with the conductor and ground. Okay. The ground in an electrical system is conductor, and it's used to protect against faults in electrical system and does not normally carry currents. Another way that you become part of the electrical current is to come in contact in both conductor and being supplied with power and in the ground. Here maybe the man doesn't wear appropriate safety shoes, then become one path. If the man is wearing appropriate shoes, so perhaps this man still will be shocked, but he will not create one path. The man will be repelled or through back. Akan terpelanting. Conductor is wire or another device that used as a path for electrical energy to flow. So yeah, this is a lot of wordings. Maybe you could read by yourself. You will become part of electrical circuit if you touch the conductor being supplied with electric energy. This example, if you apply both hands, so you can remove from one hand to another hand and pass through your hand. A severe of electric shock is directly related to the path of the current entered into the body. This is the one that we explained before this, right? Because you put your right hand and left hand. Also, when you doesn't use both hands, but you have only these two fingers connected, then still this will create a short circuit. And if you touch with both of your hand, for example, you have line 1 and line 2, also this one will get and short circuit, and when the electric will come across your heart from one hand to another hand. Okay, how you want to deal with the shock victim? So first thing, contact with the electrical source is personal safety. Do not touch the person. Do not touch the person, and then you should never come in direct contact with the victim. You should use, for example, you could use wood, whatever lah, insulator, to move out the person from the current, and then shut down the main switches. Non-conductive or insulator. And if you use non-conductive material, make sure that it's dry. I think the rest you could read. Let's go on the. Okay, this here we have another one, series parallel circuits. Before this, you have only series circuit, and then you have another parallel circuit. Here we have series and parallels, means we have it both at the same circuit. This is normally we have in air conditioning. So here we have CFM, condenser fan motor, and then we have low pressure switch LPS, we have high pressure switch HVAC, we have thermostat, we have C contactor, this is contactor, we have condenser fan motor 1, fan motor 2, CFM. Okay, since normally we have it in here. So to calculate the amount of electric current, the resistance and voltage, it is here to follow some procedures for series and parallel circuit. So here you need to know lah. If you need to calculate, you have to use the proper way to calculate lah. Then we have a power circuit. Power circuit means that the current carry power lah, or electrical loads. And then we have a control circuits. Use control device to determine the load when the load are energized or de-energized by controlling flow. For example, the control circuit is when we have a thermostat in the line or in the circuit. This example. And then we have a high pressure switch, low pressure switch in the circuit. So that one we call it as a control circuit. Okay. Power, P equal to IR, P equal to VI. This is formula. P equal to IR, or P equal to VI RE. Actually V. This is American one. Heat energy. So P equal to V squared R over R. So we have P equal to I squared R. This one you need to remember. Okay. Example. Okay, here you need to calculate what? I. Okay, calculate. These are also calculation. So for the calculation part, I will put the site. So you could download this slide, and also you could do it, and then please submit lah to the given link. Hopefully I could do the link by today. If not, just keep it first, then you need to submit. Everybody need to submit individual tasks. Don't copy. Better late than never. Don't copy, do it yourself. Better late than never. But don't do it. Don't do. If you don't do, then I will find you lah. I will find you. Not just the last time. Classifications. What happened? Yeah, I don't like to talk much. So please do it. Please do it. At least you should. You are doing something. There are some students are good and doing and ask me when the slide, but some student doesn't care much. Sorry for that. And for the COVID, not only you doing how to say that, hearing the lecture through YouTube. So it's like, I don't know, what do you feel? A bit boring, right? Same goes to the lecture, because I don't see your face. One-way interaction, so I'm not sure. But we have to face it. We have to face it because of this COVID. We have to face it. Okay, be strong. Assalamualaikum and salam sejahtera.